Hi there! Today we're going to look at 8 different ways to set up 2D movement in Unity 2D. Go ahead and start a new project and let's set up some of the prerequisites before we get into the movement. Off the bat, we have a platform that we set up here using a tile map. We added a tile map collider 2D to our tile map to simulate physics-based collisions with our player, which we have added a box collider 2D and a rigid body 2D. We're going to be simulating 2D platformer movement first. Okay, with all those set up, go ahead and create a player controller script and attach it to your player. This includes all of the different ways to simulate our player movement. We first get an inputs vector. That inputs vector handles horizontal and vertical input. For a 2D platformer, you're going to want to separate your vertical and horizontal input, as jump mechanics may be different from the way that your horizontal mechanics are applied. If we look at the handle horizontal input function, we can see that there's some animation logic here, as well as some rotation logic. And then we return the horizontal axis here. If you're not familiar with axis, you can refer to the scripting API or documentation on what input axes are. We can also look at the project settings and manage the different types of axes and see what values are returned for what buttons are pressed. Jumping back into our script, we can also see that horizontal input, just like vertical, is returned the same way. If we look at handle vertical input, we can see that we're returning vertical input here. We also have a place to add jump code logic here. As mentioned, the mechanics for jump mechanics may not be the same as handling left and right mechanics in 2D platformers. Alright, let's look at our first type of movement. Movement by translation. This movement's very simple. We simply take the transform and we translate it based off of an input differential here. We're using our speed as defined here and our time.delta time to smooth out the input's value that's returned. And the value that could be returned by a horizontal axis could be between -1 and 1, and we're adjusting these values accordingly. If you're not familiar with the time.delta time smoothing value, you can refer to the scripting API or documentation on time and the values that work with it to smooth out vectors like this. Alright, let's save that and let's take a look at in-game how it looks. Well, alright. Uh-oh. So I can move right, but when I try to move left, it still thinks I'm moving right. Why is that? Well, our translation logic doesn't get along with our rotation logic. If we comment out our rotation logic, save that, and play, we can see that translation works, and we can move left and right, but we can't flip. We can also go up and down. Okay, so that's movement by translation. Now what's the workaround for this? We want to be able to rotate our player, so let's go ahead and uncomment this. And we'll look at the second type of movement here, which is movement by transform, or position rather. And essentially we're referencing the game object transform. And we're setting the position equal to a new vector 2 here. In that vector 2 we pass an x value, which added to it we have the inputs differential for x, and we're passing in a y value for the transform position, and added to it is the inputs differential for y. So let's save that and take a look at what that looks like. Okay, so I move left, and I move right, and I move left, and move right. Awesome. So this is transform position based movement. We can also move up as well. Kind of interesting. Okay. Let's take a look at the third type of movement. This is physics-based movement. In particular, it's physics-based movement by velocity. So what we need to do here is get the rigid body 2D component attached to the player, which we can see declared here. And then we'll set the velocity of that rigid body 2D to a new vector 2 with the calculated rigid body velocity for x, and added to it is our inputs differential, and we're doing the same thing for y as well. So essentially the same as what we're doing for the transform.position logic up here, except for physics-based velocity movement. So let's save that and take a look at what this type of movement looks like. Okay, that's kind of interesting. It's a little slow. We can also go up. If I hold the up, we get this float type effect. Let me turn up the speed value inside the inspector from 5 to 10. Okay, so we kind of have this sliding momentum motion type movement, which is cool. Whoa! Okay. Velocity is awesome. Let's take a look at the next type of movement, which is force-based movement. So we're still using the rigid body 2D, but instead of setting the velocity to a set value, we're actually adding a force using the add force function, and we're passing in an input differential here with a force mode. And we can change this force mode to the particular type of force mode we're trying to use, whether it be force or impulse. And if you need more information on force mode and the way that forces work in Unity, you can definitely refer to the scripting API or documentation for that. Let's keep it at force for now. So just like our translation logic, we pass it the input differential here with our smoothing time and our speed value. Let's save that and see how that looks. I can't move. Well, let's change the speed value. Since we're using a force, I'm going to change it to 300 and see how that looks. Oh, okay. Whoa, that shoots me way off. So I tried to jump, and it shot me way off in the air. So you can see how the jump mechanics for your player could be very different from the mechanics that are used in calculating left and right movement. So that's something to keep in mind. Alright, so those were the first 4 ways. Now the next 5 ways can actually be very simply done by taking the inputs vector that you have here, using it just the same way you've done with all of these other types of movements, except we're going to do one thing. We're going to turn off the rigid body. In particular, we're going to turn off the gravity scale. So we're going to set this to 0. The rigid body 2D now has 0 gravity. We come back into our script, and we're going to first test the force movement. So this is the 5th type of movement that we're looking into. You can see that we get a very interesting float type effect. Now I am a little slow, so I'm sure I have to turn this up a little bit. Yeah, so if I turn it up to 25, Force movement is a little bit different now. So you can see how this can maybe be a space type game. And the same goes for using velocity and having the gravity value set to 0 inside of our rigid body. We can press play, test our game, and you'll notice that you as well get maybe like a spaceship in space type movement here. Very satisfying to watch. Very nice. And that's velocity. I float away in space. And then with transform position type movement, when we have the rigid body gravity scale set to 0, this will be the 7th type of 2D movement. Now we're going from platformer, from space simulation game, to top-down RPG type game. So that's transform position type movement. And we go back to translation logic now. And we test that. And that is our translation logic. And of course our rotation value is affecting our movement again. So we just go disable the rotation logic here. For translation, and this is the 8th and final method in this video to create 2D movement in Unity 2D. That is your translation based logic here. Alrighty, so that wraps it up. Thanks for watching. I hope you learned something today. That was 8 different ways to set up 2D movement, and that is just a small handful of the various ways that you can set up movement in your Unity game. Thanks for watching. Bye-bye.